ਬੱਚਿਓ ਆਪਾਂ ਗੱਲ ਕਰ ਰਹੇ ਸੀਗੇ ਲੀਨੀਅਰ ਪ੍ਰੋਗਰਾਮਿੰਗ ਦੀ। ਵੀ ਵਰ ਟਾਕਿੰਗ ਅਬਾਊਟ ਦਾ ਲੀਨੀਅਰ ਪ੍ਰੋਗਰਾਮਿੰਗ ਪ੍ਰੋਬਲਮ। ਲੀਨੀਅਰ ਪ੍ਰੋਗਰਾਮਿੰਗ ਪ੍ਰੋਬਲਮ we are taking a case of this is a problem. Basically this is the problem. This is the minimization problem. Minimum z, it is given to x1 plus x2, x1 plus x2 subject to 2x1 plus x2 greater than equals to 4. Another constraint, there are two constraints which are given to us, x1 plus 7x2. x1 plus 7x2 greater than equals to 7, x1 comma x2 greater than equals to 0. I am again repeating the problem. Minimization x1 plus x2. This is the objective function which is minimization subject to 2x1 plus x2. This is the first constraint greater than equals to 4. The second constraint is x1 plus 7x2 greater than equals to 0. We will solve this problem with couple of methods. Because the number of variables are 2, so the best method is the graphical method. Let us take the graphical method. I am taking the graphical method. First of all, we will take in the graphical method. We will get the same result by making use of all the methods. But let us start with the graphical. This is the first constraint. This is the second constraint. What is the first constraint? 2x1 plus x2. It must be equals to. When it is equals to, means x1, x2. We are taking x1 on this side, x2 is here. When x1 is 0, x2 is 4. When x2 is 0, x2 is 2. So let us take this is 1, this is 2, this is 1, this is 2, this is 1, this is 2. 1, 2, 3, 4. This is 3, this is 4. 0, 4, this is the coordinates. 2, 0, this is the coordinates. This is the first constraint. Because it is linear in nature, so you will get a straight line. Is it okay? What is the second part? 2x1 plus x2 greater than 4. We are left with this one. Means put the origin to be 0, 0. When the origin is 0, 0 is greater than 4, it is false. Once it is false, it is away from the origin. It is away from the origin. This is for the constraint 1. This is for the constraint 1. Go to the constraint 2. x1 plus 7x2 is equal to 7. Again, because it is linear in nature, we will identify the extremities point. When x1 is 0, x2 is 1. When x2 is 0, x1 is 7. So 0, 1. 0, 1, this is the point. Go to the up to the point 7. Up to point 7. This is 3 here, 4 here, 5 here, 6, this is 5, 4, 3, 6, this is 7. This is 7. Clear? When I join, this is the point, these are the 2 points. Clear? This is the constraint number 2. We are left with the second part. x1 plus 7x2 is greater than 7. Put the origin to be 0, 0. 0 is greater than 7. It is false. If it is false, here it was also false. If it is false, it is away from the origin. It is away from the origin. This is the constraint number 2. Now, what is the area which is satisfying both? This is the area which is satisfying both. This is the region which is satisfying both. And what is the minimum value? Look at the minimum value. Because the function is of minimum, if we keep on here, if it is a maximization problem, the value will go up to the unbounded solution. means there is no boundary, it will go to the infinite. But here the problem is of minimization tape. So our solution will lie here. Our solution will lie here. So these are the 3 points. Start with the A point. This is B. This is C. Now what is A? ZA. What is ZA? We are getting the value of x1 is 0. And what is the value of x2? X2 is 4. So the minimum value is 4. What is ZB? We'll calculate the ZB. Let us calculate ZC. ZC means x1 is 7, x2 is 0. So this is 7. So total sum is 7. Now this point either you can locate it by the graphical method, or the second thing is do it like this one. When it will be equals to, this is equals to, when this will be equals to, these two constraints are equal in nature, you will be able to get the x1, x2 values. Let us multiply this by 2. This is 2. Here it is 14. Here it is 14. Clear? Here it is 14. Now, if I subtract it, this is subtract. I subtract it. This is cancel out. Minus 13 x2 is equal to minus 10. x2 is equal to 10 by 13. Clear? We got x2 is equal to 10 by 13. So substitute x1 is equal to 7 minus 7 x2. Clear? This is 7 minus 7, x2 is 10 by 13. Put the value here. Take the 7 minus 17 over 13. Take the LCM 13. This is 91 minus 70. This is 21 by 13. So we got two coordinates. This is 21 by 13, comma 10 by 13. Clear? So we got these two coordinates, 21 by 13 and 10 by 13. I substitute here. This is 21 by 13 plus 10 by 13. This is 31 by 13. So out of 3, this is the minimum value, because 4, if I divide by 31 by 13, it is a 2 point something. It is 2 point something, means this is the minimum value. So results are x1 is 21 by 13, x2 is 10 by 13, and z minimum, the z minimum is 31 by 13. So I put it here, x1 is equal to 21 by 13, x2 is equal to 10 by 13, z minimum is 31 by 13. Now we'll solve the same problem with the other method. What is the other method? We'll get the same results. So we will do the A-Charnes method. We'll solve the same problem with the A-Charnes method. Why A-Charnes? Let me explain that one. That is also known as the big M method, method of plenties. We'll solve the same problem with the same another method. If the number of variables are 2, the best method is the graphical method. But let us solve this with the big M method also. So if you look at this constraint, first constraint, this is the question. First of all, convert it into the maximization problem. This is maximum z dash is equal to minimum of z. Minimum of z. And I multiply whole question by minus sign. And here this left hand side is on greater than side. So what happened here? 2x1 plus x2 minus s1. I add it here 0 times s1. This is equals to 4. This is equals to 4. Go to the second constraint, again x1 plus 7x2. Left hand side is greater than, so again we introduce a slack variable s2, that is again it is equals to, put a same value 0 times s2 here and minus s2 here, it takes us to 7. So this is the feasible alternative constraint, x1 comma x2 s1 s2 greater than equals to 0. When you put the initial basic feasible solution, first of all calculate, let us assume I calculate IBFS first of all. What is here IBFS? x1, put the origin values or the variables values to be equals to 0. When I put the 0 to be here, this is 0 here, this is 0 here, you got the s1 is minus 4. and similarly S2 is also. So it is not satisfying, This is not satisfying this feasible alternative. Why? X1, X2 could be 0, which is satisfying, but S1, S2 should be greater than or equals to 0. Here it is, these values are negative, so this is not satisfied. So what we have to do? We'll work on that one again. 2x1, I take the same constraint, x2 minus s1. I have introduced artificial variable a1. Whenever any constraint is greater than equals to then from the right hand side, we will always introduce, or we will have to use the big M method of plenty. A. Charnas is the scientist who gave this method. So it is equals to 4. I add it here, I give a plenty here in objective function minus m times a1. Now go to the second constraint, x1 plus 7x2 minus s2 plus a2 is equal to 7. I introduce minus m times a2, minus m times, because the function is of, I have converted into a maximum function type. Maximum z dash is equal to minimum of z. I have converted this minimum function to the maximum one. So again, your feasible alternative, it has been changed. x1, x2, s1, s2, a1, a2 greater than equals to 0. Again put IBFS. What is IBFS? x1 is equal to x2 is equal to s1 is equal to s2 is equal to 0. Means I am going to introduce this and slack variable also to be a 0. If you put it here, from here what we get a1 to be positive. Similarly from the second constraint we got the a2 to be positive. These values are 4 and 7. Whether it is satisfying this feasible alternative constraint? Yes, it is satisfying. x1 can be 0. x2 can also be greater than or equals to 0. Similarly, s1, s2, a1, a2, all are 0 or greater than that one. So what we got in our objective function, maximum z dash is equal to minimum of z. If I substitute the values, maximum z dash, this is 0 here, this is 0 times s1, it will be 0. So 0 times s2 again, s2 is 0 also, but multiply with 0. So what we got? We got 4 plus 7, 11 m. We started with, this is 4, a1 is equal to 4, a2 is equal to 7, this multiply with 4 m, 7 m, and this is 11 m. So we started with this solution. So we'll perform the iterations also. Let us perform the iterations. Again this thing we are going to perform the iteration. We will proceed further. I make a block like this one. So what is here? This is called CSV. What is CSV? This is called current solution variable. This we have already discussed in the last class, current solution variable. But here the method is a big M method, or the A. Charnas method, or method of plenty. Then in a order of, whatever the order is there in objective function, x1, x2, s1, s2, a1, a2. Clear? Then on the right hand side we take the value b. What we got from this constraint a1, from a first constraint we got the value of a1 having objective function minus m. The coefficient is minus m if you look at here. Similarly from a second constraint we got the a2, the value is minus m in objective function. So let us substitute here 2, 1, minus 1 from a first constraint, 2, 1, minus 1, coefficients of x1, x2, s1, a1 we are going to substitute here. So similarly go to the second constraint, this is 1, 7, 0, minus 1, 0, 1, this is 7. And here it is Cj, this is the coefficient related to the objective function. This is minus 1, 0, 0, minus m, minus m. Clear? Is it okay so far? We'll proceed further. Now calculate Ej. What is Ej? If you recall Ej, this coefficient, Ei coefficient, means minus m with 2, this is minus 2, minus m with 1, this is minus 1, and add it minus 3m. Clear? Similarly, corresponding elements for the rest of the table, do it. So this become a minus 8m, because minus m, minus 7m, we add it, this is minus 8m. This is plus m, this is plus m, this is minus m, this is minus m. Means the corresponding elements have been multiplied and added it. So this practice we have already done. So calculate Cj minus Ej. This become minus 1 plus 3m. Clear? This is minus m plus 8m. Is it okay? Minus m, this is 0, this is 0. Out of that one, if I give the value to be plenty, because the plenty, if I give a value 1000 here, 8000 and this is 3000, and minus 1 has been subtracted. So this is the bigger one. So this has been chosen. X2 is coming inside. What is going outside? What is going outside? It is being decided by the theta. What is theta? 4 b by corresponding column which has been selected. 4 by 1. This is 4 by 1. 4 by 1. This is 7 by 7. This is 1. So this has been chosen out of that one. From the theta, choose the least value. So this decides your key column. This decides your incoming variable. This decides your outgoing, and this is the key element or the pivot element. Key element or pivot element. We will work on this one, key element or pivot element. So what we have to do? We'll do the another iteration. Now in the next iteration, which is going outside, A2 is going outside. Put a line on A2. Don't put a A2 in the next iteration. So leave it. So again CSV, EI, X1, X2, S1, S2, A1. Clear? So here it is, A1 is as it is, this is minus M. A2 is going outside, it is coming, X2 is coming inside, it is having coefficient minus 1. So divide it by 7. Why? Because this has to be made unitary. This is 1 by 7, this is 1, this is 0, this is minus 1 by 7. What is A1? This is 0 here. What is the value of B? This becomes 1. Clear? So this is 1. Here it is 1, but here we have to make 0. What we have to do? 2 minus 1 by 7. 2 minus 1 by 7 means 13 by 7. 2 minus 1 by 7 is a 13 by 7. 1 minus 1, this is 0 here. S2, this is minus 1 into 0. This is 1 by 7, positive. A2 is 1. Clear? 4 minus 1, this is 3. Clear? So leave Cj as it is. This is minus 1, this is minus 1, this is 0, this is 0, this is minus m. So again calculate Ej. Again calculate Ej. When we are calculating Ej, this becomes minus 13m. Minus 13m. Clear? This is minus 1 over 7. Clear? Minus 13m minus 1 over 7. This is minus 1. Clear? This is plus m. This is minus m plus 1 over 7. Because this multiply, this is multiply, and this is minus m. Clear? So again Cj minus Ej, calculate the Cj minus Ej. When you are calculating Cj minus Ej, look at here. This is minus 1. This is minus plus, this is 13m plus 1 over 7. When I take the LCM to be 7, this becomes 13m. When you simplify it, 13m minus 6 over 7. Is it okay so far? So this is 0 here, this is minus m, and here it is m minus 1 over 7. Clear? And this is 0 here. Again, 13m and m, which one is a bigger? Both has been divided by 7. So this is the bigger one. If I give a plenty of 1000, if I give the value 1000, 13,000 minus 6. So this is 1000 minus. So this is the bigger one. This has been chosen. This decides your incoming variable, which is coming incoming. So x1 is coming inside. So here it is theta. Here it is theta. Look at here theta. When I do it, this becomes your 21 by 13. Because 7 is multiplied, 13 is divided. And here it is 7. Which one is the lower one? To decide the outgoing variable. These are both are the positive values. So this is the lower one, 21 by 13. So here it is. What is there? So this is your key element. So again we will do the iteration. I rub it here. Which is going outside? A1 is going outside. We will not get the optimal result till both A1 and A2 is going outside. So we'll do the same iteration here. I rub it here and put it here. We'll do the same iteration. Clear? So we'll do the iterations here. Let us here, clear, and here if you look at here, I do the same iteration now due to this, because I require the values of the last iteration. Look at here. Here it is CSV, EI, X1, X2, S1, S2, this is B. Is it okay so far? Now here it is, we have to make this to be a 1, which is going outside. So going outside is A1 and it is replaced by X1, having coefficient. What is the coefficient? -1. This is X2, this is also -1. It has to be 1. So multiply by 7 by 13. 1, 0, -7 by 13. Clear? This is 1 by 13. And what is B? This is 21 by 13. What is B? 21. Here it is 1 by 7, here it is 1. So what we divide whole question by 7 and take the difference. This is 0 here. What I do? 1 by 7 over 1 by 7. This is 1 here, 0 by 7 is 0. So if I do it here, I am going to divide by the 7. This becomes the 1 by 13. Is it okay? Because 0 is here and I subtract it, this is 1 by 13. And what is the value here? This is -1 by 7. Is it okay? This is -1 by 7. This is because divide by 1 over 91. Clear? I take the LCM 91. So this is -13. This is -1. This is -14 over 91. If I divide 7 2 ja, 7 and 13 7 ja, this is 13. Clear? -2 by 13. -2 by 13. Is it okay so far? So here it is 1. Here it is I divide by 7. This is 3 by 13. Basically 13 is the LCM. 13 minus 3, this is 10 by 13. Is it okay so far? So I rub it here, do the calculation like this one. Now again calculate EJ. When you are calculating EJ, this multiply with this multiply with this. Basically put it here CJ, this is -1, this is -1, this is 0 here, this is 0 here. A1 and A2 is going outside. So until and unless A1 and A2 is not going outside, you will never get the optimal result. The method which is we are going to solve this problem with the Bigham method, A. Charnath method and method of plenty. It has the same name, means same meaning. These are the different names of the same method. The method name is the A. Charnath method, method of plenty, Bigham method. So this is -1, this is -1. Is it okay? Here it is 7 by 13. Clear? Here it is -1 by 13. So what you answer you got? You got answer 13. This is 7 minus 1. This is 6 by 13. Put it here. This is 6 by 13. What is the value we are getting here? Here it is -1 by 13. Here it is 2 by 13. The LCM is 13. -1 plus 2. This is 1 by 13. Is it okay so far? Again take the difference Cj minus Cj. This is 0 here. This is 0 here. This is -6 by 13. This is -1 by 13. So once we got Cj minus Cj, either 0 or negative, the solution obtained is the optimal one. Means we can't proceed further. If we choose the 0 to be non-negative, it is already there x1. If I take this 0, it is already there. I can't take this -6 by 13 and -1 by 13 because this is the negative sign. What answer we got? We got x1 is equal to 21 by 13 and x2 is equal to 10 by 13. And what is Z minimum? If you look at here, we have converted the problem minimization into maximization, but our original problem will remain same, that is 21 by 13 plus 10 by 13. This is 31 by 13. The same answer we got with the which method? The same answer we got with the graphical method. So again with the Bigham method or the A. Charnath method or the method of plenty, we got the same answer. Let me have another thing also. So I know I'm taking another one. I'm taking the concept of the duality. What is there in a duality? Look at the original problem. I rub it here. I keep this answer. Basically, this is the answer. This is the answer. This decides your duality concept, duality theorem. I am going to discuss the duality theorem also in the same problem. So, we are discussing couple of things here. So if your original problem is of minimization time, this is called the primal problem. This is called the, let me have a primal. I mentioned a primal problem. What is the primal problem? It is of minimization time. Minimum z is equal to x1 plus x2 subject to, this is the primal problem, x2 is equal to 2x1 plus x2 greater than equals to 4, x1 plus 7x2 greater than equals to 7, x1 comma x2 greater than equals to 0. For primal problem, we have already calculated the value of x1 and x2, that is x1 is equal to 21 by 13, x2 is equal to 10 by 13, and the z minimum was 31 by 13. So here, if you look at here, we have solved this primal problem with two methods. First method, because the number of variables were 2, so we have make use of the graphical method, and the second method, because one of the constraint is of greater than equals to type. So we have already used or calculated the result with the help of the Big M method, A. Charnath method, and the method of plenties. This is, I go with the dual problem. Look at here. If your primal problem is of minimization type, your all constraints should be of the greater than equals to type, which is true there. Our dual problem will be of maximization type, and y1, y2, if I am taking x1, x2 be the x1, I have taken x1, x2 to be the variable which is given, and let, how many constraints are there? There are two constraints. So y1, y2 be the corresponding dual variable. y1, y2 be the corresponding dual variables. Is it okay so far? So if this problem is your minimization, this problem will be your maximum w is equal to, this is on a b, on a greater than equal, so you are getting 4 and 7. So this is 4 y1 plus 7 y2, clear? Subject to. So this is your dual problem, subject to. Compare the x1. Now this is 2 y1 plus y2, 1 into x1 basically. This is y2. This will be of least than equals to type, because the problem is of maximization type, equals to 1, clear? So another one, this is 1 into x2, this is basically y1 plus 7y2, why? Because 7x2, again less than equals to 1 when I comparing with the minimization objective function. So y1, y2 comma is greater than equals to 0. Clear? Is it okay so far? So when I substitute the value of this, decide this S1, S2, this gives you the results of y1 and y2. So basically 4 into y1, what is the value of y1? This is 6 over 13 with the sign change. Here it is negative, change it to the positive 6 by 13. This is 7 into, this is 1 by 13, clear? Basically this becomes your 24 by 13 plus this is 7 by 13, clear? If you add it, this is 31 by 13. What it proves? It proves that in a duality theorem, I mentioned it here, in a duality theorem, what happened? Minimum z is equal to maximum w. This has been proven, and we know the value of y1 and y2. What is the value of y1? y1 is 6 by 13, y2 is 1 by 13, and the answer is 31 by 13. In both cases we got the same result, 31 by 13, 31 by 13. So what we discussed today, we'll continue with the same problem in the next class. We'll take this maximum w and we'll try to solve the same results. Now again this dual to be converted to the primal problem in the next class. So that's it from my side. If you have any question, you may ask me. Thank you very much.